my name is Guy. I'm head of training at ScyllaDB. And the topic today is high performance, low latency database architecture. I gave a previous talk to a similar group on a meetup, and I got some feedback that the content wasn't technical enough. So I'll try to go into more technical, in-depth material as much as time allows. So I mentioned I lead the training at ScyllaDB. My background is as a software engineer, and I'm based in Israel. And the things that I will cover today are NoSQL in general and ScyllaDB and where it fits in the NoSQL world. Then I would like to talk about the architecture. And while I will be talking about Scylla, the same architecture is also relevant for other databases. So it's not only specific to Scylla. And then I'll give, as an example, the right path in ScyllaDB. And finally, I want to leave enough time for your questions and maybe a discussion. Before I get started, I want to mention ScyllaDB University. So ScyllaDB University covers, well, basically it's our NoSQL and ScyllaDB training and resource center. Everything that I will be talking about today is covered in Scylla University. It's completely free to get started. All you have to do is register for a user. So if I'm going too fast, if there's something I don't cover, feel free to check that out. It's a useful resource for just learning about Scylla and about NoSQL. And there's a link there, and I will share the slide deck with the people that attend today's meeting. So no need to copy or anything like that. Okay, so I'll get started with NoSQL and Scylla. Most of you are familiar with NoSQL, so I won't talk too much about it. What we see here is the CAP theorem. Generally, in NoSQL databases, the schema is more flexible, they're easier to scale, and in most cases, they're distributed. So if back in the day, I don't know, in the 70s or so, we had one large mainframe, and we would store all the data in that one big computer that was in the basement of the bank or wherever. In modern day applications, that doesn't work anymore, and we need to distribute the database for different reasons. One of them is scalability and performance. Another is also to improve the availability. So one way to classify distributed databases is according to the CAP theorem, which is what we see over here. And the CAP theorem states that in distributed databases, there are three attributes that we would like to strive for. And however, there's a trade-off between these three, and we can only pick two out of the three in each database system. So the three attributes are consistency. There are different ways to define consistency, but a popular way is that when we read data from the database, we get the most recent, right? So our data is consistent. Availability means that our database system can serve requests. It doesn't necessarily mean that the request will be consistent or the correct one, but we will get an answer. And partition tolerance means that even if there is a network failure or a partition in the network or some communication problem between our nodes, the system would still be up and running and serving requests. So as I mentioned, we have to choose two out of the three. That's the CAP theorem. And there are dozens of popular database systems. And I just put a few here on this triangle. And you can see, for example, that MongoDB prefers consistency over availability. And then traditional SQL systems prefer availability and consistency over partition tolerance. And here you can see that Scylla, as well as Cassandra and Amazon DynamoDB, which belong to the same family, they give a preference to availability over consistency. Okay, and that doesn't mean that the data is not consistent. And I'll talk about that in just a bit. Another way to classify NoSQL databases is according to the data model, and going from the least complex to the more complex here, starting with key value, for example, RocksDB, Aerospike, and some others, where we just have a key and the value. It's very simple, no need for anything like types or schema or anything complicated. We query according to the key and we get a value. It's very easy and simple to understand. More complex would be document store type databases like MongoDB, where we store documents such as JSON or XML or others. So there is some structure. And then going to a more complex data model, we would think about wide column store, which is a fancy name, but actually the data is stored in rows and columns. And examples of that are, again, ScyllaDB, Cassandra, and Amazon DynamoDB, and of course, many others. And finally, maybe the most complex would be graph data systems, where data is stored as edges and vertices. Two popular examples are Neo4j and Janus Graph. And by the way, Janus Graph can work with Cassandra or ScyllaDB as the underlying persistence storage layer. Okay, so I mentioned that Scylla is closely related to Cassandra, to DynamoDB, and this is captured here. To give some context, there was a paper published back in 2007, a very well-known popular one, the Amazon Dynamo paper, and then another one, the Google BigTable paper. Based on those two tables, on those two papers, Cassandra, which is Apache Cassandra, it's one of the probably 10 most popular databases, was developed. Apache Cassandra is open source and it's very widely used. That's around, I would say 2009, after those papers were published. And Amazon DynamoDB, based on the Amazon Dynamo paper, was also published around that time. Now, Scylla is a drop-in replacement. It's compatible with both Apache Cassandra and DynamoDB. And it's very similar in terms of the architecture to those two databases, mostly to Cassandra, but also to DynamoDB. So I would say that all of the topics that I'm going to be talking today in terms of architecture, data replication, and so on are relevant for ScyllaDB, but also for Cassandra, and in large parts also for DynamoDB. And if you have an application that's currently using Apache Cassandra, you can take your application as it is and change the underlying database to use ScyllaDB instead of Cassandra, and you wouldn't need to change pretty much anything else. You could use your application as it is, but you would get many benefits by using Scylla. And maybe I'll talk about that in just a bit. And the same goes for DynamoDB. So ScyllaDB started out around 2015. It started as a rewrite of Cassandra, which is written in Java, but it's written in C++ instead of Java. And by working very close to the hardware and avoiding all kinds of problems that Cassandra has with Java, like garbage collection and other unexpected things that are hard to control, Scylla resolves some of the challenges of NoSQL databases such as Cassandra, and it provides up to 5 times higher throughput, up to 20% lower latency, and total cost of ownership that's quite high. You don't have to take my word for it. On our website, we have a lot of benchmarks, and you can play around and test it for yourself. It's open source, so you can download the code, you can play around with it, you can compile it yourself, you can add features and so on. But we also have an enterprise version which is built on top of the open source version. And with the enterprise version, you get some extra features and also our customer support, 24/7 support. And additionally, we have a database as a service or cloud offering where we run a managed ScyllaDB cluster for you. So if you don't want to keep a database team and you just want to focus on your application, on your core business, which is probably not managing a database, you can do that. And there we take care of things like upgrades, backups, security hardening, and of course you get support. So that's becoming more and more popular. More and more people are choosing to use our cloud offering. And ScyllaDB is used by some leading companies that I'm sure you heard about: Comcast, Grab, Disney, Zillow, and some others. So it's usually large companies. We have use cases from different industries: IoT, ad tech, financials, many others, banking as well. You can look on our website for specific industries related to your use case. But basically, if you're running a database that has a lot of data, okay, and you need high availability and high performance, then I would recommend taking a look at ScyllaDB to see if it fits your use case. Some of the attributes of ScyllaDB. So I mentioned high availability, and data is replicated across different nodes. And that means that even if there is a failure in one computer or even in one data center, the system can still serve requests. Okay, so it's highly available. It's highly scalable, and that means that, let's say you have some kind of e-commerce business and it's going to be Black Friday. So you know you're going to get more traffic for your application. You can simply add more nodes in advance. There's no downtime needed. You can just do it as the application is running, and you would be able to serve more requests to your application. And then maybe after Black Friday, you can downscale. It's very easy and straightforward to do that. Performance. So we get, just to give you an idea, queries in the 99th percentile that are just a few milliseconds, maybe 5 or 10. And again, you can see benchmarks on our website. So high throughput and low latency. Low maintenance, that was one of the pain points for Cassandra users, as well as other systems where there were entire teams that played around with the garbage collection, with optimizing Java, with optimizing the system. It was not very stable and it required a lot of maintenance. So with Scylla, maybe if we have time, I'll show you some numbers, but you can run on less servers, you can get better performance, and the system auto-tunes and auto-configures itself, so you don't have to worry about garbage collection and so on. I already mentioned Scylla is a drop-in replacement for Cassandra and for DynamoDB. I won't talk too much about that, but with DynamoDB, if you're not happy about being locked into a specific vendor, Amazon in that case, you can use ScyllaDB instead. Again, it's open source, it works with different cloud providers, and you avoid the vendor lock-in. Okay, going into some architecture. So I mentioned that Cassandra and other databases are using the thread model. That means they have a thread pool, and whenever there is a job to do, the system chooses one of the threads and the thread performs that job. And what we get there is we get a lot of wasted resources, context switching, and sometimes resources are locked. Whereas Scylla uses the shard per core architecture, and that means that we have one core with its own memory, its own RAM, its own network, and its own disk, and that's allocated to a specific set of data that it's responsible for. And that keeps things much more orderly, and that translates to improved performance. And here in this slide, what you can see is you have the same number of puppies and bowls of food, but with the thread model, everybody's fighting for food. Some bowls are empty, food is spilled on the floor, and it's quite a mess. Whereas the shard per core architecture, every puppy is eating from their own bowl, and everyone's happy. Okay, so I put here a link to a lab that you can actually run from your browser and just start a 3-node ScyllaDB cluster running with Docker. It runs, as I said, from your browser, so you don't need any prerequisites to install anything. You can do it from any browser. But again, because we have limited time, I don't want to show you how to do this. You can do this on your own. It's available on Scylla University and also in the slides that I will share with you after the meeting. Okay, so maybe before we move on, just to make sure you're with me, have you heard of ScyllaDB before, or is it your first time? If you can answer in the chat window, one option is I have not heard about it. The second is I've heard about it, but I haven't used it. And the third option is I'm a ScyllaDB user. So a lot of people didn't hear about it, or first time. I see some of you did hear about it. Okay, but I can see you're still listening to me, and that's a good sign. Great, so let me continue going into the architecture. Okay, so just to make sure we're on the same page, let me talk about some basic concepts. So I mentioned a Scylla node. I didn't really explain what a node is. So a node is basically a computer server running the Scylla software. It's basically a server running Scylla. And typically, when we run a cluster, it consists of a few nodes. And each Scylla node is responsible for a part of the database content. And again, I'll mention this because it's important. Everything that I'm saying right now is relevant for Scylla, but also for Cassandra, most of it for DynamoDB, as well as other databases. So in Scylla, all the nodes are equal. We don't have any idea of master, slave node, or leader, follower, any other name you want to call it. All the nodes are created equal, and that goes together with high availability, okay? So that means that even if one node fails, the other can still provide service and answer requests. In a typical cluster, we have in production at least 3 nodes, and we have examples of clusters with hundreds of nodes. So as I mentioned, it's highly scalable, and we think of a cluster as a node ring, but that's just the way to conceptualize it. The communication between different nodes is done peer-to-peer. So they communicate directly, and again, there's no single point of failure. The way that data is partitioned is according to something called the partition key. This goes into data modeling, which I won't get into, but basically the way the system, the database knows which node is responsible for which row is according to the partition key. And what the system does is it performs a consistent hash function. It executes it on the partition key, and according to the value, it determines which of the nodes are responsible for this specific row or piece of data. Okay, so choosing the partition key is, of course, very important. And each node that we can see here is responsible for a set of token ranges. Okay, so this, of course, is a way to simplify it, but it helps to understand. I mentioned data is replicated. So again, going to high availability, we keep multiple copies of each piece of data, and that is determined according to something called the replication factor. And this is something that the user can configure. So in this example, the replication factor is set to 3. And that means that each piece of data that we have in our system, each row, will be replicated or copied to 3 different nodes. So we have 3 copies of each node. And again, that goes together with high availability. Say we have a 5-node cluster and the replication factor is 3. So even if one of our nodes that holds our data goes down, is unavailable, there's an earthquake, a fire, a network failure, whatever, we can still serve requests because 2 of the nodes are still available. Okay, now it's important to understand that what I'm explaining to you is something that happens under the hood. Okay, so as a user, you define the replication factor, but the system automatically replicates the data for you. You don't have to worry about that. Another important concept is the consistency level. Consistency level is also something that's defined by the user, and that is the number of nodes that must acknowledge a read or a write request. Okay, now that can be configured even per query. So it might be that I have a query where I need to get very consistent data. So I can set the consistency level to be high. Whereas maybe for another query, say I'm writing the temperature of a room for an IoT application every second. So maybe the consistency level for that write is not that important, right? Because it's happening every second anyway. So point being that the consistency is tunable and we can set it per operation according to your application needs. And finally, I mentioned data centers, but Scylla as well as Cassandra are built for multiple data centers. So in this example, we have a data center in the US and a data center, say, in Asia. And that makes sense for a number of reasons. One, more common recently is that we might want to have all the data in the same geographic location for regulation reasons. Maybe the data from the US cannot leave the US, so we can keep it only in the US data center. The second reason would be for performance reasons. So it would make sense to serve a user with requests from the US data center and not from the Asia data center. And later the data centers can sync between them. I don't remember the numbers, but I think it's about 100 or 200 milliseconds just physically for the signal to move from one side of the world to the other. And the third, again, is availability. So even if we have a rack or an entire data center going down, in some location, we can still serve requests because we have redundancy from another data center. Okay, we're almost out of time. I wanted to show you a read or write level, what happens in the interaction, but we're almost out of time. So let me skip this part. I put a link here to another lab that's more advanced, and this is the high availability lab. Here again, from your browser, you can start a 3-node Scylla cluster, and you can perform different queries. And in this specific lab, you can see what happens when some of the nodes are down. Okay, so we simulate a situation where a node becomes unavailable, and then we see how the database interacts with the client when nodes are unavailable. And again, it also shows what happens with different consistency levels and different replication factors. All this information is covered in ScyllaDB University. And you can also feel free to reach out, ask me any questions. So here, maybe very quickly, I'll show an example from one of our customers, ScyllaDB versus Cassandra. So they were using Cassandra. As I mentioned, it's very popular, and they moved to ScyllaDB. We had 4 ScyllaDB nodes compared to 40 Cassandra nodes, and they got up to 22 times better latencies, and the system was much less expensive. So lots of benefits. More resources. I mentioned Scylla University. we have a community forum where you can ask questions. We have a Slack channel, over 6,000 people. People from the community help each other. And also ScyllaDB University Live, you could click on that. And this is a more in-depth live training event. It's happening next week. It's a half day. It's completely free and it's online. You can join the event. We cover different topics. Some are more advanced, some are for beginners. And you'll also have a chance to ask any questions about your specific use case that you might have, because right now we don't have a lot of time, but still I would like to take a few questions in the few minutes that we have left. Any questions, please?
This is Jeff Privilege. I had one question for you. Maybe it's too big of a topic.
Sure.
So feel free to say out of time.
Yeah.
Can you touch on encryption and all back and forth between the user and the database?
So the question is about encryption. Yes. So there are two types of encryption. The system is encrypted, and one is encryption at rest. That means that the data is encrypted while it's located on the database, and we have that option. And also encryption at transit. So both of those options are available. If I remember correctly, one of them is enterprise only, but I'm not so sure about that. So
okay,
we would have to check that.
Oh, good. Okay, thanks.
Sure. I see another question about a certification track. So that's a good question. There are recommended tracks. So the university has 6 different courses. You can just pick and choose different lessons according to what's interesting for you, but there are also tracks that you can take, starting with the most basic course and then moving to more advanced ones. And when you complete a course, you get a certificate, which is just like a PDF file with your name and date and so on. And you can also share that on LinkedIn or on any other media. So we do have certification. And also, by the way, the live event that I mentioned is also people that complete it also get a certificate and maybe some t-shirt or something like that. So we do have that. Great. So thank you, Richard. I hope you enjoyed the presentation. Maybe next time I'll take a bit longer than half an hour because I didn't really have time to go over everything that I planned. But yeah, stay tuned. We'll do another meeting like this, hopefully. And if you have any question, feel free to reach out to me. My email is guy@ScyllaDB.com. You can find me on the Slack channel, also on the forum. And as I mentioned, I'll make sure we send out the slide deck. Thank you, Ron. Yeah, we'll send out the slide deck to everybody that's attending and the links and so on. So appreciate your time. Thank you, everyone, and hope to see you around. Ciao.